Okay, guys, now we're going into the system. To solve the system, guys, there's one of two ways, but the most popular way is to plot this into a graphing calculator. But see, I'm not going to be there to help you with your tests, especially on the STAR tests. You'll have to be able to do that on your own and understand that to solve a system is to find the crossing point. When do these two cross? So if you understand that solving a system is when those two cross, then you would automatically think, oh, well, I could just use a calculator, a graphing calculator for that. So I'm going to go into my Desmos graphing calculator, and I'm going to place the two equations that was given to me, 3y equals negative 6x, 3y equals negative 6x, and plus 13. My second equation is 3x minus y equals 4. 3x minus y equals 4. And I get this crossing point. Now, before we move on to what we were doing, guys, the thing about this is that even though we're able to calculate the crossing point with Desmos, when you guys get your actual calculators from the school, you must turn these into slope-intercept form for the graphing calculator to read it. So if I were you, I'd already get into the practice of like rearranging everything before you put it into Desmos, so that way when you do go back to school, it won't be like, you won't be shocked like, why isn't my calculator working? But then again, in our TI Inspires, I highly suggest that you, like I said, you rearrange everything. So that's easy. Like I would divide by 3 to both sides, and then I get y is equals to negative 2x plus 13. And this one, I would have to subtract 3x to both sides. So then I get negative y is equal to, now I could write 4 plus negative 3 or 4 minus 3x, but I'm just gonna like flip it because I want it to be in that slope-intercept form. So I'm gonna put negative 3x plus 4. And I want to get rid of this negative symbol. I'm going to divide by the negative. And y is equals to positive 3x plus 4. So this is something you'll have to do when you go to school, especially when you go to high school. You'd be using that calculator that makes you solve, that requires you to input it as slope-intercept form. So if you want to go the extra mile and already start doing that, I highly suggest you do it. If not, if you're not too comfortable doing that, then yes, you could just put it into Desmos because it will do it for you. It doesn't matter if it's in standard form or whatever kind of mixed form. But the overall concept of this is, when do the two lines cross? So I can easily click onto my Desmos, and I could see that the two lines cross at 1.66 and 1. So that would be my solution, 1.66, where x is equal to 1.66. Remember, we got to know what x and y is to our solution, and 1. Okay, the long way, like I've shown you guys before, is also to solve through elimination. Okay, so solving through elimination is when you have your equations lined up and you pretty much combine like terms vertically. You add your equations. This requires for us to basically rearrange everything though. So similarly to what I did when I was showing you on the Desmos calculator, I'm going to divide by 3 to both sides. The first equation becomes y equals negative 2x was it 13? Plus 13 divided by 3. Okay. And then I could easily put that in the calculator. And then now I'm going to move 3x to the other side, to the next equation, because this equation's pretty much set. Like this is already good. Now I just need to rearrange this. So I got negative y is equal to negative 3x plus 4. Then I'm going to divide by the negative. So the official slope-intercept form to the second equation will be y, because I'm going to divide by the negative, is equals to positive 3x plus 4. Okay, once I've done that, I gotta like change them to where they're the inverses of each other by multiplying by some number to make it that way. But you guys get the idea on how to solve through elimination. You would have to add down, but converting your equations into the inverse of one another. I know it's a lot of work, but for now, we'll stick to graphing.